This is essentially my magnum opus of the Jeep mod world. So in an earlier video I have this OBD2 to Wi-Fi adapter. It uses the ELM327 protocols, and here I have an Arduino with an ESP8266 Wi-Fi chip built in. So I've been building for months the code to connect to my Arduino to the OBD in the car and like send and read commands so I can get data, such as I get the RPM, engine coolant temperature, and throttle position, and then I run my own algorithm based off of that to send a voltage to the idle air control valve, because that just hasn't worked in my car for almost 4 years. So I'm going to go over the algorithm that my code is running. So it's running it in a loop. About every 3 seconds it's going to run this to compute how much voltage we want to output to our motor, which in this case is the idle air control valve. So every 3 seconds we're going to take inputs which my Wi-Fi chip is getting from the OBD Wi-Fi adapter. So it's taking in 3 inputs: RPM, engine coolant temperature, and throttle position percentage. And it's going to use these in the algorithm, and based on those compute how much voltage it wants to put out. And it's going to pulse width modulate this voltage in order to give it a varying voltage. So essentially what we're doing before we get into the algorithm is just, this is what I want it to look like. So I want it to give about 9 volts when, so this is coolant temperature at the bottom, voltage on the right. So if it's, the engine's cold, so I'm saying just less than 75 degrees, I chose that arbitrarily, I'm just going to give it 9 volts. And then I want the amount of voltage that I give it to decrease as the engine warms up. 212 is about the maximum temperature it gets to. 4.5 volts is about the minimum voltage I found the IAC needs to function, and I just found that through trial and error. So it's basically just a piecewise function. So I'm just giving it 9 volts until 75 degrees, and then I'm just doing a line. So like y equals mx plus b. I've got the equation right here. So slope times the coolant temperature plus 9 mx b. And that's how I'm going to compute it. But so anyway, in code format, so the reason I need RPM and throttle position are, so I only want the idle air control valve to be given voltage and to let air in if basically my foot's off the gas and I'm idling. So if throttle position is less than about 17%, means my foot's off the gas, that's a little higher than it needs. And if the RPM is less than 1,000, again a little higher than it needs, just so it'll maybe kick on a little earlier. And so within this if statement we have another nested if statement. So again, I'm just turning this line down here into code. So if the engine coolant temperature is less than 75 degrees, I'm going to output 9 volts. And then, so if it's else, meaning it's not less than 75 degrees, so it's above 75 degrees, so I'm going to output this line. So it's going to calculate it based on the coolant temperature. So it's just going to multiply this by negative 4.5 over 12, so it's going to decrease the higher the coolant temperature gets, and then add 9. And then I'm going to write out this value. And that's basically it. So I'm also thinking about doing an electric fan install, and for that all I'd really need is the coolant temperature as an input and calculate when to turn the fan on or off, just simply based on that. And this whole circuit right here is basically using a field effect transistor, a MOSFET, to pull voltage and current from the car battery, because the Arduino is only running on 5 volts and that's not enough to power the idle air control valve. And so these wires go to these 2 sets, one goes to the battery, one goes to the IAC. And so I'll include like a circuit diagram and all the code, but I've been working on this project for probably 7 months. It's been a long time, and it's finally working. And so for the last 4 years what I've been doing is to start it, I would keep my foot on the gas, and then I use this hand throttle here to simulate like there's always a little bit of air being let in because the IAC wasn't working. But now, as you can see, I can start it. I have the hand throttle all the way down, foot not on the gas, and we'll start it up. And it's idling. I'm still getting a check engine light, but I mean, I'll deal with that later. I'm pretty impressed right now just that it idles on its own. So unfortunately, when I finished all my code and went to try and power the IAC, I was unable to, because the Arduino is powered by 5 volts, and that's only just barely enough at a maximum if you put out the maximum output from the Arduino to power the IAC, if you just wired the Arduino straight to the IAC. So what I had to do instead was I needed to use the car's battery power, which has 12 volts at its disposal. So, but I couldn't just always supply 12 volts. I had to find a way to modulate that. So what I did is I found a MOSFET, or a metal oxide semiconductor field effect transistor. So you really just want any sort of field effect transistor. So, I mean, I had options of relays, transistors, or transformers. And a transistor is really your best bet because they can switch on and off really fast, especially a field effect transistor. So all that I'm doing in order to vary the amount of voltage that I'm giving the motor from the car battery, so I'm not always giving it 12 volts, is I'm basically turning that transistor, this MOSFET, off really, really fast. And that essentially mimics giving it a lower voltage, right? So if you turn it off really, really quickly, back on and off really quickly, it will give you a higher voltage. And if you turn it off like in longer cycles, it'll give you a lower voltage. So essentially what's going on here is I have a 10 kilo ohm pull-up resistor coming out of the Arduino. You want your source coming off the MOSFET, drain, ground. You need to make sure you have a diode going around the motor to avoid any reverse voltage spikes so you don't fry your motor. So one other thing that I found that I had to add was I had to add 2 diodes coming out from where the ECU was already wired to the IAC, because otherwise, so really this ECU is also connected to the battery, and it was just opening up a whole nother circuit, and it was giving it that constant 12 volts. It basically wasn't being regulated by the MOSFET. But yeah, so I'm going to post like a still image, right, so you guys can look at it. But this is the schematic that I came up with, and it works perfectly. So here it is in a slightly more finished product. I got it on a soldered breadboard, solderable. So one thing I need to do is I need to buy a long Arduino power cord. See, I have it powered here in a USB adapter, so I can run that and make that neat. And I'd like to 3D print a box that I can mount here with a cover, so one, I could keep it clean because I get a lot of spray from having my tires stick out that'll get this muddy, and I can mount it here nicely. But yeah, it came out really well. I'm very happy with this.